Welcome, good afternoon, good evening, good morning, depending on where you have joined from. This is the second webinar for the year 2024, and I'm glad that we are continuing the trend that we started off last year, and we delivered so many webinars. All the webinars are recorded and are available on sqlmaestros.com. So the link is sqlmaestros.com. If you go up there, you will be able to find all the recordings. So a common question gets automatically answered, which is this webinar will also be recorded. So welcome once again. Today's topic is T-SQL tips and tricks part 2, which means there was part 1 that was delivered last year in the month of November, and the recordings are again available on sqlmaestros.com or even on our YouTube channel, youtube.com/sqlmaestros. What are we intending to cover today? Today, we are going to talk about 4 tips or 4 tricks, whatever you call them. We are going to discuss the optimize for hint, which we can use sometimes for cardinality fix. We'll look into the demo and I will explain what I mean by cardinality fix. We will also look at the over clause. Then we'll look at a common application requirement, and SQL people keep doing this all the time, which is removing duplicates from a table. So we're going to look at this technique as well. And then another application requirement, which is recursion, trying to achieve recursion inside a table, the data that we have in a table. So we have precisely 4 demonstrations to do today. Now, before I continue with the content, or rather start off with the content, I'll just take a minute and tell you that some of this content is taken up from our popular masterclass, which is called as SQL Server Internals Troubleshooting and Performance Tuning. Some of you probably are aware of this. This masterclass, 40 hours content, was delivered last month in the month of December 2023, 40 hours online program, and it was very, very successful. That class is recorded and the recordings are now available on sqlmaestros.com. Here is the content in front of you that was delivered. So if you look at all the 14 modules, a lot of deep dive stuff, 40 hours program. So we covered the breadth as well as the depth. Sometimes people ask me what kind of program they should really go for. And I'll tell you honestly, just not because it's my class, it's because the fact that this is all really what you need, because we cover everything from start to finish when it comes to performance tuning. Now, in case you want a link to the recordings, it's there in the chat window. I've just put it. So that's up there in the chat window. You may want to bookmark it or browse that later. So let's just quickly see this one. Okay, and I can just show this to you. So if you go to sqlmaestros.com and you go to master classes, and here you have browse class recordings. If you click on this, you'll land up on this page where you'll see right in the front, SQL Server Internals Troubleshooting and Performance Tuning 40 hours program. Click on this and you have all the details. Just a quick thing to note, if you subscribe to the recordings, you get a lifetime subscription. Unlike many other online programs, which are annual subscriptions or subscriptions for 2 years, this is lifetime. So you just pay once and you get the entire content for life. This is for the community. And of course, there is 60% off and whatnot, which is an introductory price, and that might change. So if you are someone who is very keen on deep dive content and you want lifetime access and you want 60% off everything, this is the right time to go for. So the link is there in the chat window. That's all I wanted to kind of publicize a bit before we start off today's content. All right. T-SQL tips and tricks part 2. As usual, the common housekeeping announcement is feel free to punch in your question in the Q&A panel. Please avoid the chat window. Q&A panel is the right place where your questions should go. And I'll take, after the demo, maybe I'll answer a few questions, or maybe I'll complete all the 4 demos and take all the questions at a stretch. At least I'll ensure that I am able to complete all the 4 demos. Okay, friends, so let's get started. First trick, which is optimize for cardinality fix. Let's get started. We use AdventureWorks 2016 for the purpose of demo. We have a table here called sales order header, and this table sales order header has one record for each order. One of the attributes here is the salesperson ID. And of course, a common requirement here could be to find out the orders or the number of orders by a specific salesperson ID. So the application may write, or the application user may write a query like this. So you want the salesperson ID, you want the count, which is how many orders, and you group by salesperson ID. So let's go and turn on actual execution plan, and let's go and execute this. Now, what you see here is starting from 285 all the way up to 277. So 285 is the individual, the salesperson, which has the least number of orders, 16 orders, and 277 salesperson ID has maximum number of orders, 473. Now, this query is all good. This is ad hoc query that is written. Everything looks all good. But let's say the requirement here is not to write a aggregation query like this. The requirement is that maybe, let's say it's a parameterized report where you punch in a specific salesperson ID. So now when you say 285 has 16 orders, let's look at a query like this where you say select star from sales order header where salesperson ID is equal to 285. Now 285 will not be hard coded. It won't be a constant here. It's going to come via a parameter. Now in disguise of a parameter, we use a local variable for T-SQL here. So we declared the SPID. Now this SPID is not our SQL Server process ID. This is salesperson ID local variable. And we set SPID to 285. So if you go and execute this, and I've turned on actual execution plan, let's go and execute and see what we get. Okay, we run this and we get 16 rows. So you know that 16 orders by salesperson ID 285, and you can see in the status bar there, we have 16 rows. Everything is good. Now let's jump over to the execution plan now. If you go over to the execution plan, and I am going to take the cursor over here. Okay, so you will observe that actual number of rows is 16 and estimated number of rows is 1748. Now, this is what we mean by cardinality estimation error or incorrect or inaccurate cardinality estimation. When there is a huge gap between estimation versus actual number of rows, things are not good. There might be scope of improvement here, which is what you want to fix. So one small thing here is we checked the execution plan. We got a scan plan. We took the cursor over the arrow between the select and the filter operator, and there is a cardinality estimation issue here. Don't worry about the row numbers. Row numbers are what I showed you here right now, which is 16 versus 1748. Now, 1748 versus 16 seems to be a huge gap. So now this was when we used the local variable. Now, just for the change, like instead of @SPID, if you put 285, you hard code the salesperson ID, and let's go and execute this. Let's see what the optimizer does. If you go and execute this now, jump over to the execution plan. Wow, now you get a seek plan. This is interesting because earlier when you had used the local variable and you were actually substituting the local variable, you were getting a scan plan. Now you get a seek plan. Let's take the cursor over the arrow here and let's see actual versus, okay, let's put it here somewhere. Okay. Actual number of rows versus estimated number of rows, 16 and 16. This seems to be very good. This seems to be accurate cardinality estimation. So the question is, what really is going on? Okay, so let's do one thing. Let's go and change this back to SPID. Okay. And what you did here was, let's go and execute this once more and let's copy this. And why not show both the things to you? Okay, so let's put this here and let's put 285 here. And let's go and choose a vertical tab group. And let's go and turn on the actual execution plan for this. Let's go and execute here. So this is the plan that you get when it is hard coded, and this is the plan that you get when you use the local variable. Wow, this looks good now. Okay, now we'll do a small trick here. Instead of supplying 285 as the value for the local variable, let's go and change it to something like 277. Okay, I don't know 277 exists or not, doesn't matter. Let's go and put any value. Okay, let's go and execute this. Okay, 277 does exist. Oh, and we get maximum number of rows out there. Let's go, jump over to the execution plan. We are again getting a scan plan. Take the cursor over the arrow here. Now you see 473 rows and the estimation is 1748 again. So what is interesting to note here is that actual, of course, keeps changing because that's the runtime statistics, but estimation remains same when you use local variable 1748. What I'm going to do, I'm going to do something very funny now. I'm just going to punch in a salesperson ID that does not exist. Okay. Something like this. This is just a random number. This salesperson ID does not exist. When I go and execute this, you will obviously get an empty result set because this SPID doesn't exist. Let's jump over to the execution plan. Take the cursor over the arrow. You will see actual number of rows 0, but estimation is still 1748. Now this will get some bells ringing into your head as to what is going on. Okay, so here is the answer to the mystery. When you use a local variable in your T-SQL code, something like what I've done here, the optimizer does not have the value of the local variable until runtime. So during the optimization and compilation phase, the optimizer does not know what is the value being held in this local variable because the local variable value assignment happens at runtime. So the optimizer does a default guesswork. There is a hard-coded code in the optimizer's code, and that default guesstimate, right? That default guesstimate is being used. And that default guesstimate doesn't change because it is hard-coded. So irrespective of any salesperson ID that you put here, irrespective of any value that you assign to the local variable, that's going to remain same. And that is why you always see 1748 as the estimation. But the moment you hard code here, like 285, okay, let's ignore this. This is not part of this. When you say 285 here, you get 16 versus 16, right? As you see in the tooltip there. If you change it to 277, which has maximum number of sales, let's go and execute this. Jump over to the execution plan. Take the cursor over somewhere here, and you will see 473 versus 473. When you put 277 here, you have observed another thing. Let's copy this one and let's copy this one. 277 to 85. Let's go and execute both of them now. And what you are going to see is 277 rightly gives you a scan plan and 285 rightly gives you a seek plan. In case you're new to SQL Server, you would be wondering, why am I getting a scan plan versus why am I getting a seek plan? Simply because 277 gives you about 500 records. So according to optimizer's cost estimates, a scan plan or a scanning operation is more cost effective than a seek operation. So 277 with 400 rows or whatsoever gives you a scan plan. 285 merely returns 16 rows. And according to optimizer's cost estimate, seeking for 16 rows is more cost effective than scanning the entire table. So you get a seek plan. So everything is all good. The estimations are good. And based on those estimations, you get the optimized plan when the parameter value, when the predicate values are hard coded. But the moment you take local variable here, right? The moment you declare a local variable and you do a variable runtime assignment, things just go so bad. You are always getting a scan because the estimation always is 1700 rows. So you're always getting a scan. And that's why when you put 285 here now, and because you've put 285 here now, you know that seek would have been a better plan. But unfortunately, because of this hard-coded design in the SQL Server database engine, the optimizer engine, the local variable runtime assignment, you know that scan is not the right choice. This plan is not optimized given the local variable value. So what you could do is now, first things first, friends, are you all understanding what we're talking about, right? This is just the problem. We haven't even arrived at the solution. The problem itself has so many dimensions and directions. How is it going? Are you all getting what we're talking about? Yes, in the chat window. Maybe some yes, no, maybe, or no, I'm lost. And maybe I got a feedback sometime back that I haven't understood what you have said, but whatever you have said is all great. Okay. So those of you who have joined a bit late or with so much of discussions around, you are maybe a bit confused. I'll just try to simplify it real quick. When you put different salesperson ID, Optimizer is smart enough to give you the right execution plan, the optimized execution plan based on the parameter value, because it knows the parameter value during optimization and compilation phase of the execution plan. So for 277, you get a scan. For 285, you get a seek. Why? Because 277 gives you more number of rows, 285 gives you less number of rows. Everything is all good. But the moment you change the code and you start using local variables, Optimizer uses a default guesstimate, a hard-coded concept there, and is always giving you a scan, because here the estimate is always 1700. Okay, now T-SQL tip and trick. You want to fix this, okay? So one solution here is you may want to use a hint called optimize for. Now the same code has been written. This part of the code is same. We just add a query hint here. We say option optimize for @SPID equals to 285. So you are hinting the optimizer. You're telling the optimizer that, you know what, this is my code. I understand that you will not have the value of the variable until runtime, but for the optimization and compilation phase, may you please use 285 as the value for this local variable @SPID. Now what the optimizer is going to do is, while it's optimizing and compiling the execution plan for this query, it's going to take 285 into consideration. So when it takes 285 into consideration, you should be getting the same execution plan that you see on the bottom right-hand side, which is this seek plan. This is what you should get. Let's check this out. Let's go and execute this now. Okay, you get 16 rows as expected. Let's jump over to the execution plan. Boom, there you go. Cardinality fix. That's why I use the term cardinality fix. So you can use this technique, you can use this trick to tweak or tune your T-SQL ad hoc code. Now, a bit of warning and caution out there. While this trick looks really awesome, wow, we have just fixed something, which was like probably bothering us, and we are getting an optimized plan. But using a query hint should be done with a lot of caution and warning. It's not a permanent solution. It should be used as the last resort in your query tuning endeavors. There are so many different things that you might want to try before using a query hint. And also, query hint, according to me, according to my experience, should never be a permanent thing in your production. It might be a temporary solution, something like a temporary relief while you work on other things. Let's say a query is performing very bad and you're just trying to figure out the skewness of the data, how the data is being laid out. The table is so very huge and you're trying to figure out a lot of different things. And till such time, you put a query hint as a temporary measure to improve the query performance. But it works well. It works good in a lot of cases. All right. So now, there are questions coming in already. Something like, how do you provide these hints in production? Well, if you're thinking about, okay, I can't put this code in my application, how can I change it on SQL Server? Well, then explore Query Store. Explore Query Store. That will help you freeze a specific plan. Of course, this session may not be the right session where we talk about Query Store. But yeah, in my masterclass recordings, I do talk about Query Store, and I show you such things like freezing a specific plan that works for your query. For example, now this query has a scan plan and a seek plan. Query Store will capture both of them. So I can freeze a specific plan to be used all the time. All right, so this was the first trick, friends, to fix cardinality issue, which can be done using optimize for. Optimize for a specific value. and that does a lot of good there. Okay, a lot of questions coming in, friends. Please use the Q&A window. If you're typing in your question in the chat window, I will probably not look into them. I will request you, because it's difficult to monitor two places. So please punch in all your questions in the Q&A window. Please avoid chat window. Okay, and I will answer them at the end of the session. Okay, let's move forward. This was the first tip and trick, which is optimized for. Let's jump down. Okay. Let's talk about another technique, another tip here, another trick, which is over clause. Let's close this one now. Okay. Over clause. I discovered this when I was working with ranking functions, when ranking functions were introduced in SQL Server 2005. And this is great. It's a shortcut technique with the optimizer. Better to explain this with a demo. Let's use pubs database here. In case you are a veteran with SQL Server, you would know about these databases like Northwind and pubs. This was with SQL Server 2000. I still have a copy of this database. Now look at this query. There's a table here called sales. And for whatever reason, I want to compute multiple aggregates in this sales table. So there is an attribute here called quantity. We want to get the sum, the count, the average, the minimum, the maximum, and whatnot. Just trying to show you that we are computing 5 different aggregates, and each aggregate is a subquery, right? This is a self-contained subquery. So if you just take this and execute, you will get the output, right? So you're getting a sum. If you just take and execute this, let's go and execute this, you're getting the quantity, right? And then average, so on and so forth. Now, I am going to run this entire query, and of course, execution plan is turned on. Let's just go and execute this. Okay, you get all the output, you get the attributes, and you get the necessary aggregations that you had asked for. Let's jump over to the execution plan. Look at the execution plan now, and I'll give you a few seconds. Can you identify any issue here in the execution plan? If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on sqlmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to sqlmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are 2 membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on sqlmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So, in summary, you can go to sqlmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on sqlmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL!